Hello guys, how are you today? So today I'll be explaining the Math AMS quiz of Term 2 Week 9. So let us start with the first question. We have that KLMN is a parallelogram. We are given that LM is 5 centimeters, MN is 3 centimeters, and LN, which is the diagonal, did not draw it correctly, it is 3.2 centimeters. HG is an arc of a circle centered at K of a radius 1 centimeter. That means this over here is how much? 1 centimeter. Okay? Now let us see what they need. First, they need us to find the measure of angle LKN. To find the measure of angle LKN, very simply, what we can do is we can take this side. We know the side is 3 centimeters. And this side over here, we also know that this side is 5 centimeters. And we are also given the diagonal, which is this side over here. And we found it to be how much? 3.2 centimeters. Now what we're going to do in this method is we're going to use the cosine rule because we have 3 sides and we need to find the angle. So what we're going to do is we're going to take the 2 sides that make the angle, or the 2 sides that are next to the angle. We are going to square them and add them. So it becomes 3 squared plus 5 squared. Then you are going to subtract the opposite angle minus 3.2 squared over what? Over 2 times 3 times 5. So if we put it on a calculator, 3 squared plus 5 squared minus 3.2 squared over 2 times 3 times 5, you are going to get an answer of 0.792. Now what you are going to do is on the calculator, you are going to do cosine inverse or shift cosine of the answer, which is 0.792, and you are going to get approximately 37.6. If you round it to the nearest degree, it is 38 degrees. So our answer is 38 degrees. We move on to part B. In part B, they are telling us, use your answer in part A and fill in the blanks. Rounded to the nearest whole number, they need the area of the shaded region. How can we find the area of the shaded region? Very simply, what we could do is we could find the area of the parallelogram, which is the full thing, and then we would subtract it from the area of this sector over here, minus area of the sector. So very simply, we need to find the area of the parallelogram, and then we subtract it from the area of the sector. Okay, so very simply, the area of the parallelogram can be found in 2 ways. Either by finding the height, and how do we find the height? Since we are given this angle over here to be 38 degrees, and we have this side over here to be 3 centimeters, we can very simply find this. So we are dealing with what? With opposite over hypotenuse. So you will do sine 38 is equal to opposite side h over hypotenuse 3. So it becomes 3 times sine 38, which is going to be 1.8. So you found the height to be 1.8. And now it is perpendicular to which side? It's perpendicular to this side. So that means what? That means to find the area, you are going to do 5 times 1.8, because it's base times height in a parallelogram. And you are going to get that the area of the parallelogram is 9.23. Now another way to do it is that if you don't have the height, what you could do is you could take side times side. You will multiply side times side. So it's going to be 3 times 5. But instead it is multiplied by the sine of the angle in between them. So it would be 3 times 5. I think my tablet moved. I don't know if I can move it back. Yeah, like that. So it's going to be 3 times 5 times sine the angle in between them, which is 38. Okay, and you're going to get the same answer, which is 9.23. Now, so far, what we have found is the area of the parallelogram. However, how do we find the area of the sector? Very simply, the area of any sector is equal to the angle over 360 times pi times r squared. So the angle we have over here is 38. 38 over 360 times pi times the radius. We know that the radius is found to be 1. So 1 squared. If you put it on the calculator, 38 over 360 times pi times 1 squared, you are going to get an answer of 0.33. Let us just say 0.332. So now what we are going to do is we are going to take 9.23 and we are going to subtract from it 0.332, and then we would be left with 8.898. So they said round it to the nearest whole number, so you are gonna round it and it's gonna become approximately 9 centimeters. So just like that, we found what? We found the area of the shaded region to be 9 centimeters. Now they need the perimeter of the shaded region. What is the perimeter of anything? It is all sides added. So very simply what we could do, we can play smart. There's no need to think too much about it. We know that the perimeter is all of the sides added. So they need it of the shaded region. The shaded region is this, which is 5 centimeters, and this, which is 3 centimeters, and then this, okay, plus this. Now how do we find this? Very simply, you are gonna take, this is in total 3 and this is 1, so 3 minus 1, you are gonna be left with 2, and this is in total 5 and this is 1, so 5 minus 1, you're gonna be left with 4. And now you are left with this side over here. How do we find this length over here? We call the arc of the sector the length of the sector, and the equation of the length of sector is very simply angle over 360 times the circumference, which is 2 pi r. So in this case, it's gonna be 38 over 360 times 2 times pi times 1. So if we put it on the calculator, you are gonna get an answer of 0.66, okay? So very simply, what you're gonna do is you're gonna add them all. So it's gonna be 5 plus 3 plus 4 plus 2 plus 0.66, and you will get an answer of 14.66. They need it to the nearest whole number, so you are gonna round it again and you're gonna get approximately 15. So very simply, the answer over here is 15. Now this is it for question number 1. We move on to question number 2. They said, referring to the figure below, O is the origin. OA is A and OB is B. Okay, you have to pay attention. So look, OA, it's starting from O, ending at A. OB starting at O, ending at B. Okay? M is a point on AB such that AM to AB is 1 over 2. So that means M is what? M is a midpoint. This is very simply what they are trying to tell us. Now, they said, which of the following is true? Let us take them one by one and solve them. They said, select the 3 correct options. We have OM is equal to 2A plus B. Let us see, what is OM equal to? OM, you are starting at O and ending at M, okay? It is equal to 2A plus B. This is what they have said. So let us see. We know A, again, is equal to OA. And then B is equal to OB. So they are saying that M is equal to 2 times A plus B, so it's equal to 2 times this. So it's going to be something like this. Plus 2 times this. Is it equal to this? Definitely not. It is not equal to this, so this is incorrect. Let us actually find out what it is equal to. What we should learn from before is that when you are saying anything towards the midpoint, it is equal to half of the opposing segment. Meaning that line OM, or not line, sorry, ray OM is equal to half of the opposing segment, which is AB. Okay, this is a very important thing we need to know. Okay, and AB, what is AB? You're gonna say AB like this. We will take it AB like this. So OM is half of AB like this. If we are gonna break down AB, okay, you are gonna see that it is OA plus OB. So that means OM is equal to half of OA plus OB. And we know that OA is A and OB is B. That means, very simply, OM is equal to half of A plus B. So we fix this. It's not 2 times A plus B. It is actually half times A plus B. Now they are telling us AM. AM, what about AM? We know that AM is what? AM is equal to half of AB. Okay, but let us see what are the options they have given us. They said that AM is equal to half of A minus B or B minus A. Whenever they say minus A or minus B, that simply means the opposite. So if A is equal to OA, then minus A is equal to AO. If B is equal to OB, then minus B is equal to BO. Very simply, this is what it means. So we are looking for what? For AM. And how do we find AM? Okay, so we are discussing about AM. Okay, but what you should know is that when we are dealing with the vectors, the starting point or the initial point, which is this point over here, has to always start with a starting point. Yani if this is the starting point of AM, that means if we are building it, that means the starting point of the second one or the original ray is supposed to be at the same point of the starting point of AM, if it makes sense like this. Okay, so that means the ray is supposed to be going like this, and that means it is AO, and AO is minus A. Now, the end, okay, if you elongate it's like this, supposed to be something like this. And again, we know what? We know that AM is equal to half of AB. So let's say you took AB as a full, okay? The end of AB, it has to meet with the end of what? The end of the other ray. So terminal has to meet with terminal, and initial has to meet with initial. So here, over here, the initial points are meeting, and over here, the terminal points are meeting. So for this one, it is OB, that means it is plus B. So in another term, you can write AM, it is equal to what? It is equal to half of B minus A. And that is how we found the second one, where AM is half of B minus A. We move on to the next one, which is AB. We need to find the value of AB. Very simply, again, like we've said many times, we're going to take AB as it is, and then terminal with terminal. So it's going to be terminal with terminal going like this, and then, initial point with initial point, and then terminal with terminal. So it's gonna be like this. As you can see, the two initial points meet over here and the two terminal points meet over here. So this is AO, and remember we said AO is minus A, and this over here is OB, and remember we said that OB is plus B. So that means finally that AB is equal to B minus A. So if you're gonna put it as an answer, it is gonna be B minus A. We move on to the next question, which is question number 3. Over here, they told us which of the following vectors is equal to mn minus kn. Very simply, you're going to take mn. Mn, it starts from n, so the initial point is at m, and it ends at n. This is the terminal point. Minus kn means the opposite of kn, which is going to be then nk. That means if we're dealing with nk, that means n is the initial point, and k is the terminal point. And remember, when we are drawing, we take initial with initial and terminal with terminal. So that means our answer is gonna be MK. As you can see, it is way easier than you thought. So just remember, initial with initial and terminal with terminal. Okay, so again, our answer was gonna be MK. We move on to question number 4. It is a similar concept. They said they need KL plus LQ. So again, KL, you're gonna take it. Initial is K, terminal is L. My bad, I did this wrong. Like this, something like this. And then LQ, the initial is L and the terminal is Q. Okay? So very simply, you're gonna take initial with initial and terminal with terminal, so you get the answer to be KQ. So very simply, the answer is gonna be KQ. We move on to question number 5. They asked us which of the following is the circumference of a circle of radius 4 centimeters. We should know that the circumference of any circle is 2 pi times the radius. The radius is 4 centimeters, so it's 2 pi times 4, so mentally it's gonna be 8 pi. So the circumference of circle of radius 4 centimeters is then 8 pi. Okay, so we move on to the next question, which is question number 6. Which of the following is the area of a circle of a radius 5? When we are talking about the area of any circle, it is pi r squared. So in this case, it's going to be pi times 5 squared. So you can write it as 25 pi. Pay attention, this is wrong. Or you take it as 5 squared times pi. It does not matter the order, just it matters what you put. So 5 squared pi is correct, but if you put 25 pi, if you put 25 pi, yes, it's correct. But 25, this is 2 times 5, which is 10 pi. But no, we want it like this. So that means the correct answer is 5 squared pi. So we move on to question number 7. The diagram shows the results on a coding test for 2 groups of students, labeled class M and class N. The mean score for class M is 59.5 and the mean score for class N is 62. Students pass this test when they score 50 or above. So keep this in mind. They will pass the test when they score 50 or above. Now, they said, looking at the mean scores, the students from class N claim that they did better than class M at the test. Give one mathematical argument, one or more, not necessarily only one, using the graph that the students in class M can use to show that class N may not have done better. First of all, when looking at the graph, we know that from 50 onwards, it is passing. So as you can notice, there is more students in class M that is passing. In total, how many students is passing? 4 plus 4 plus 2. So 8 plus 2, so 10 students are passing in class M, whereas in class N, how many are passing? 2 plus 3 plus 3 plus 1, 9 students are passing, so only 1 student more is passing. The next one, or the next idea, is that as you can pay attention, in the 80 to 89 score, there are more students from class M that scored it. So more students in class M scored 80 to 89. Now finally, in general, if you ignore these failing scores, you could see that, just by looking at the graph, class M is just in general higher or doing better than class N. So these are all the proofs you need to state. So more students in class M passed the test, more students in class M scored 80 or above, and then the students in class M did better than those in class N. So definitely all of the above is the correct answer. So we move on to question number 8. A cyclist rode 3 consecutive laps around a flat, keep in mind, a flat 10-kilometer track. This graph shows how the speed of the cyclist varies on his second lap around the track. The origin of the graph refers to the starting point. That means over here, this is the origin of the graph. So they told us, what is the approximate distance from the starting line to the beginning of the longest straight section of the track? Very simply, the longest straight section, as you can see, is this section over here. And from the starting point to this section over here, there is an approximate distance of 5 kilometers. So you just need to say that it is 5 kilometers. Where was the lowest speed recorded during the second lap? So during the second lap, they want us to find the lowest speed. You're gonna take it here. And it is approximately at 8 kilometers. So at approximately 8 kilometers, they recorded the lowest speed. Now, what can you say about the speed of the cyclist between 4 kilometers and 5 kilometer marks? So very simply, what you're going to do is you're going to go 4 kilometer, 5 kilometer. As you can see, it is increasing. So all you need to say is that it is increasing. Now, they said, here are the pictures of 5 tracks. In each track, S marks the starting point. They said, along which of these tracks was the cyclist riding to produce the speed graph shown earlier? So as you can see, in around the first kilometer, his speed is decreasing. That means he has to be going up. So let's say this is the first kilometer. He is going up. So definitely his speed is gonna decrease. Then, going on from his first kilometer to the second kilometer, his speed is increasing. That means he is going down. This is all about logic. So first he's going up, then he's going down again. Then he has a constant speed, if he has a constant speed, that means he is gonna just like be moving regularly. So he's gonna continue going down. Then he stops and he goes down again. That means he must have been biking up again. So look, he went up, then down. Now he needs to go up again. So change your perspective, change your point of view so that this arrow is pointing upwards, okay? And as you can see, he is moving what he is gonna be moving up. So he's gonna be exerting more force. So he has to increase his speed. Or sorry, not increase, his speed is gonna definitely decrease, because like if he's exerting more force, that means his speed is not gonna be as constant as the first one. It is gonna decrease and whatever. And then he just has, again, constant speed. That means he's moving constantly. So from here, he's just moving constantly. And then finally, he goes down again. That means he is going up again. Let us say he's going up like this. And then his speed is increasing, so he's going up again. And then finally, it is going constant. So it's all about logic. So if you're gonna start, let's say you did not know that it was B at first, okay? You have pictures of 5 tracks. You will use the process of elimination. So for the first one, his speed is decreasing. That means he is definitely going up. So you're gonna eliminate all of those where he is going down. So you're gonna eliminate this one. And you're only gonna eliminate this one, okay? Next, we move on. Then his speed is suddenly increasing. That means he has to be going down again. So he's going up, and after he's going up, he's going down. So you are gonna cancel the one where he's not going down. So you're gonna cancel this one and this one, and this one is already cancelled. Okay, and that leaves you with B and D. Then he has a constant speed. That means he has to be moving constantly after he is going down. So as you can see over here, after going down, he is not moving constantly. He's gonna turn again. So this is incorrect, and that leaves us with the only answer to be B. So if you do not know how to solve this, you have to use the process of elimination. Okay? So now we will move on to question number 9. A research team is building wind power stations. These stations use the power of wind to create energy. The research team measures the electrical energy in kilowatt hours. The team builds the model with the following specifications. The height of the tower is 118 meters, the number of blades is 3, the length of one blade is 25 meters, maximum speed of rotation is 20 rotations per minute, the price for construction is 2,400,000 Zs. Then the turnover is 0.10 Zs per kilowatt hour generated. However, the maintenance is 0.01 Zs per kilowatt hour generated. And finally, the efficiency is that it's operational 97% of the year. Now, we go down. In part 1, they're saying which of the following statements can be deduced from the specifications of the model. Based on the specifications of the model, one of the options is that the power station is not operated on exactly 3 days of a year. They want on which basis, on which logic? They want on the logic that, okay, if it's operational 97% of the year, and they took that a year is how many days? It is 100 days, whereas we know, in fact, it is not 100 days. It is 365 days. Okay, so what they based their number of days on a year is incorrect. So if you were to take 100 minus 97%, which is the 3% of the year not being efficient or being inefficient, so it's gonna be 3 over 100 times 365 days. You are gonna get 10.95, so it is not working approximately 11 days of the year and not 3 days of the year. Moving on, they said the maintenance cost of the power station corresponds to approximately 10% of its turnover. Let us see. The maintenance cost is 0.01 Zs over the turnover, which is 0.1 times 100. If you put it on the calculator like that, so 0.01 over 0.1 times 100, you are going to get an answer of 10. So definitely, yes, this is correct. Now they said the construction of 3 such power stations will cost more than 7 million Zs in total. Well, for sure, if for one power station it costs 2,400,000, so you're gonna do for 3 power stations 2,400,000 multiplied by 3, and you are gonna get that it is 7,200,000. So definitely it is greater than 7 million. Okay, so definitely this is also correct. And then they said the maintenance cost of the power station depends on the speed of the wind. Definitely it does not depend on the speed of the wind. Like, think logically, it does not make sense. How come the speed of the wind will affect the maintenance cost? No, this is a basis of inflation and economics and business and nothing to do with the speed of the wind. Okay, so now we move on to part 2. The research team proposed the following equation to estimate the financial gain GZs over a number of Y years if they build the model described above. They said, based on this formula, I don't know what this is in white, let us ignore it. So based on this formula, what is the minimum number of years of operations required to cover the costs of construction of the power station? To cover the cost means that there is no debt, or like there is no negative number in the solution. So how do we find it? We're going to take the equation, we're going to make it equal to 0. That means you have 0 remainder, that is negative. Okay, and you will just move this to the other side. You get 600,000 years is equal to 2,400,000. So on the calculator, you are going to do 2,400,000 divided by 600,000 years, and you will get an answer of 4. So it takes, in general, 4 years, okay, 4 years is the minimum number of years of operation required to cover the cost of construction of the power station. Okay, so now we move on to question number 3. They said, what is the maximum speed that the end of the rotor blades move? So let us go up and gather all of the information. First thing, let me try to draw what we are dealing with over here. So we have, this is the turbine. It has 3 blades. So let us say, let me try to draw it better, like this. It has 1, 2, 3 blades, okay? Now, when the blades are moving, they turn in the direction or in the shape of a circle. So we know that we are dealing with a circle. And to find the maximum speed, pay attention, the maximum speed that the end, we're talking about the tips of the rotor blade move. So we're talking about the circumference of the circle. So very simply, we're going to find the circumference of the circle. To find the circumference of any circle, it is 2 pi r. Now, here is something a bit tricky. To find the radius r, we know that it is 25 meters, and it is correct. 25 meters is our radius, but when we're multiplying the circumference, okay, 2 pi, we're not only going to be multiplying by to find the distance, or like the total distance that the blade moves. No, because if you only multiply by 2 pi, you're finding the distance. No, we need to find the speed. So to find the speed, we first need to find the rotation per second. Okay, so remember, it is 2 pi times 25 multiplied by the rotation per second. To find the rotation per second, very simply, because remember, we're always going to take the basic unit, which is second. So rotation per second, it is going to be the 20 rotations per minute divided by, we know that a minute is 60 seconds. Now you could do it like this, or another way to do it is, you know that the circumference of any circle is 2 pi r, but now you are going to change it because the units they need it is in kilometer per hour. So you're going to change the radius from meters into kilometers. So you're going to divide 25 by 1,000, and you are going to get an answer which is 0.025. So it becomes 2 pi times 0.025 multiplied by, now since they need it per hour, the rotations not per second but the rotations per hour. Very simply, to find the rotations per hour, you're going to take that, it's 20 rotations per minute, so it's going to be 20 times 60 rotations per hour. So to find the maximum speed that the end of the rotor blades move, you are going to put on the calculator 2 times pi times 0.025 times 20 times 60, okay? And you're going to get approximately 188 kilometers per hour. So again, all you need to know, when this question comes in the exam, because it's PISA, I know it's going to come the same, just remember this equation. What you're going to do first is you're going to find the circumference, so it's 2 pi r, and then you are going to multiply it by the rotations. If you're using r in meters and they need it in kilometer per hour, then you're going to do rotations per second, and then you are going to multiply it by 3.6. Or if you want it in a quicker and faster way, you're going to do 2 pi r, but you're going to change the radius into kilometers, and then you're going to multiply it by the rotation per hour. RPH means rotation per hour. Now, very simply, this is it, and the answer is 188 kilometers per hour. We move to the next question, which is question number 10. Also a PISA question, I think. They said, triangle KLM is a right triangle with the right angle at K. First of all, we know it's a right triangle, so we're going to cross out everything that is not a right triangle. Then it has its right angle at K, so everything that is not a right angle at K, we are going to cross it out. So we are left with what? 1, 2, 3 options, okay? Then they said that N is the midpoint of the line KM, so you have to go back up and you will see, okay, KM, N is the midpoint, and they're doing it for the 3 of them, okay? That means the 3 of them is a possibility. Now they said P is the midpoint of KL, so we will go to KL and we will see that the midpoint is P. Now they said Q is a point inside the triangle, so again, we should see Q should be a point inside the triangle. That means we cross this one out. We are left with 2 options. Alright? And now the line PN is greater than the line PQ. So what you should know is that the line PN is supposed to be greater than the line PQ. And now just like by assumption, if you look over here, the line PN, is it greater than the line PQ? Here it looks like they are the same size. Whereas here PN is definitely greater than the line PQ. So very simply, the answer for this one is gonna be B. Just read whatever, okay, they are given, try to apply it, use cancellation, okay, and you will get your answer. We move on to question number 11. Okay, now this is a very, very nice question. It came in last week's quiz. I did not know how to solve it because we did not take it yet, but now that we know how to take it, I'm gonna explain this specific one because it has a cone being cut. A cone is cut along the line OM and is opened out into a sector as shown in the diagram below. Fill in the blanks with a whole number. The sector angle X equals what degrees? We need to find the sector angle X. Very simply, to find the sector angle after opening the cone, you have 2 ways to do this. You either have the first way, which is you're going to take the circumference of this small circle at the bottom, the small circle of the cone, okay? So we're gonna call it circumference 1 over the circumference of the whole circle, okay, over circumference 2. So you have circumference 1, which is circumference of the circle at the bottom over the circumference of the bigger circle. Or you have another way, which is the same way but just like without the circumference. You're gonna take the radius of the bottom, so you're gonna say radius 1 over the radius of the bigger circle over radius 2, and now for both of them you are gonna multiply it by 360 degrees. So let us say we took circumference 1 over circumference 2. We know that for this one it has a radius of what? Of 4. And this has a radius of what? Of 10. So circumference 1 is gonna be 2 times 4 times pi, so 8 pi over what? Over 2 times 10 times pi, which is 20 pi times 360. If you put it on your calculator, you are gonna get an answer of 144 degrees. Or what you could do is you could take the first radius, which we found to be 4, over the second radius, which we found to be 10, times 360, and you will also get 144 degrees. So either way, you have the sector angle to be 144 degrees. Now, what is the area of the shaded region rounded to the nearest whole number? They need us to find the area of the shaded region to the nearest whole number. Very simply, to find the area of the shaded region, we're going to find area of the sector and subtract it from area of the triangle, and we will get that area of the shaded region. So to find the area of the sector, it's going to be 144 over 360 times pi times the radius. Remember, we're taking it from a full circle. It's going to be this over here, which is 10. So times 10 squared. Remember, the area of any sector is angle over 360 times pi times r squared. Okay. Then we are going to subtract it from what? From the area of a triangle. The area of the triangle, you have both sides being 10, 10, and the angle in between them being 144. So you're going to use the sine rule, which is 1 over 2 times side times sine the angle in between them. So if you put it on the calculator, 144 over 360 times pi times 10 squared, okay, minus 1 over 2 times 10 times 10 times sine 144. If you put it on the calculator, you're going to get approximately 96 centimeter squared. So the answer is, I think I hit my glasses, 96 centimeter squared. So we move on to question number 12. The surface area. The surface area of a right rectangular prism with side length 6 cm and 4 cm, whose height is 10 cm, is how many centimeters squared? Very simply, what is going to happen is we're going to imagine this is the rectangular prism. It looks something like this, okay? Now, we're dealing with the rectangular prism, yes? So, the surface area is the addition of all of these sides. So what's going to happen is that you're going to find the area of this side. So it's going to be, let's say, width times width. And then this side, which is length times width. And then this side, which is also length times width. And then this side and whatever. And it's going to be really, really confusing. Or you could memorize this equation. Okay? Or you could very simply memorize that the surface area of the rectangular prism, or more specifically a right rectangular prism, it is 2 times length times width plus length times height plus width times height. So what's happening is you're taking each component. We know that in a right rectangular prism, we have length, width, and height. And then you're multiplying each of them by each other. So length times width, length times height, and then width times height. You're just like making sure that everything is being multiplied. And then you're multiplying it by 2. So because you have, okay, length times width, let's say this is the height and not the width. Length times width, you have it on this face and on the bottom face. This is 2. Length times height, you have it on this face and on the other side face. And then width times height, you have it here, and on the other face here and here. So just like in general, memorize this equation. You could understand it that, okay, I have length and width, the length and height, and then the width and the height, and then they're both happening on 2 sides. So it's going to be 2 times length times width plus length times height times plus width times height. Okay, and then you could put it and you could solve it. So very simply, it's going to be 2 times 6 times 4 plus 4 times 10 plus 6 times 10. Of course, it does not matter the order. So if you put it, it's going to be 2 times 6 times 4 plus 4 times 10 plus 6 times 10. You are going to get an answer of 248, and the answer is 248. We move on to question number 13. Question number 13. Fill in each blank with a whole number. A solid cylinder has a volume of 125 pi centimeter cubed and a height of 5 centimeters. Very simply, we know that the volume of a cylinder is going to be pi r squared h. Okay, this is of the cylinder. So very simply, we are given what? We are given that the height is 5 centimeters, the volume is 125 pi centimeters, and they need us to find what? They need us to find the radius. So 125 pi is equal to pi r squared times 5. So divide both sides by 5 pi. You're going to get 25 actually, not 5, is equal to r squared. So radical, you get that r r, not r squared, is equal to plus or minus 5. Of course, you cannot have a negative side, so it's going to be plus 5. So you found the radius, which is going to be plus 5. Now, a solid cone with height 9 centimeters is attached to the cylinder to make a new solid. They want us to find the total new volume of this solid. So very simply, we know that the area of a cone is very simply the height over 3 times pi r to the power of 2. Okay, don't forget this. Height over 3 times pi r to the power of 2. This is the volume, and sorry, not area, the volume of the cone, okay? And we already know that it was given above that the volume of the cylinder is 125 pi. So, to find the volume of the cone, we're just gonna substitute the height by 9, and the radius is gonna be the same. So pay attention, if a cone is put on top of the cylinder and they fit perfectly, that means the radius is gonna be the same for both. So if this is 5 centimeters, then this one is also 5 centimeters. Okay? So then it's gonna be 9 over 3 times pi times 5 squared. So it's gonna be 3 times 5, so 75 pi. So very simply, we have 75 pi over here and 125 pi over here. Now very simply add up and you are gonna get 200 pi. So the total volume is 200 pi cubic centimeters. Now here is where we use the similarity theorem. A solid similar to that of part B has a volume of 5,400 pi centimeter cube. The radius of the cylinder of this new solid is, they need us to find it very simply. We said similar. Similarity rule is that you're gonna take the new volume, you're gonna put it over the old volume, and you're gonna get an answer which is 27. Now, if you remember that if we did side over side, we got a constant. Okay? If we did area over area, we got constant squared, and if we did volume over volume, we get what? We get constant cubed. So constant cubed, because we did volume over volume, is equal to 27. So very simply, the constant is equal to the cube root of 27, which is 3. So we're gonna take the old radius, which was 5 centimeters, and we are gonna multiply it by the constant 3, and we are gonna get an answer of 15 centimeters. We move on to question number 14. Okay, so the volume of a sphere of radius 6 centimeters is, we need to find it. Very simply, volume of a sphere, it is 4 over 3 pi r to the power of 3. Okay, very simply, put it on the calculator. Without pi, you don't need to put pi, so it becomes 4 over 3 times the radius, which is 6 to the power of 3. You are gonna get 288, and now you can put the pi, so 288 pi cubic centimeters. Now B, the sphere is placed in a cylindrical container of a radius 7 centimeters filled with 1 liter of water as shown in the figure below. Okay? 1 liter of water is 1,000 centimeter cubed. Okay? If you go down, they said rounded to the nearest centimeter, they need the new height of the water in the container. To find the new height of the water in the container. Now, very simply, again, let us read what they wrote. They said this sphere, the sphere that we calculated above to have a volume of 288 pi, is placed in a cylindrical container of radius 7 centimeters. So the cylindrical container has 7 centimeter radius. They told us that it's 1 liter of water, so 1,000 centimeter cubed. This is the volume of water as shown in the figure below. They need us to find the height h. Very simply, what we're going to do is we're going to find the total volume of the liquid. Okay, so it's going to be 1,000 centimeter cubed plus 288 pi. If you put it on the calculator, you are going to get 1904.778684. Okay, on the calculator. Then we know this is the volume of the liquid, so it is in the shape of a cylinder, and we know that the volume of a cylinder is pi r squared h. To find the volume, to find the h, the height, we know what pi is. Pi is 3.14, obviously, and we know what the radius is. It is 7. So very simply, you're gonna take this and you're gonna divide it by pi times what? Times 7 to the power of 2. So if you put whatever answer you got on the calculator, it has to be this one, of course, divided by pi times 7 to the power of 2, you are going to get an answer which is 12.4, and if you approximately round it, it is then 12 centimeters. So this is the height. We move on to question number 15. A train started from rest at 7 o'clock. Okay, whatever. Here, all you need to pay attention to is the distance traveled. So the distance traveled is 63 kilometers. They need the maximum speed attained during the trip. We know that we have a velocity time graph. Whenever we have a velocity time graph, what we need to do to find the distance is find the area. So when you find the area of the velocity time graph, you are gonna get the distance, which is 63 kilometers. So how do you find the area of a trapezoid? It is 1/2 it is height times base 1 plus base 2/2. Okay? So the height in this case is the velocity that we need to find. We'll just substitute it with v. We have base 1, which is 45 minutes. If you want to have it in hours, you divide it by 60, it's 0.75. So 0.75 plus 1 entire hour over 2 is equal to 63. So you're going to cross multiply. V times 1.75 is equal to 126. Divide both sides by 1.75. You will get that the highest speed or highest velocity is then 72. So the answer over here is 72 kilometers per hour. So we move on to part B, which is the average acceleration of the train during the first 5 minutes. To find the average acceleration in a VT graph, we're going to do y minus y over x minus x. So over here, you're going to take v, which we found to be 72, and the other one, which is 0. And then the time difference is 5 minutes. If you want to change it into hours, you divide it by 60. So then it's going to be 72 minus 0 over 5 over 60 minus 0. So it's just going to leave you as 72 over 5 over 60. If you put it on your calculator, 72 over 5 over 60, you will get an answer of 864. So very simply, the answer over here is 864, not 5. That was a typo. We move on to question number 16. They said in the diagram below, OA and OB are two perpendicular radii of length 35. They said using pi 22/7, what is the area of the shaded region? Very simply, to find the area of the shaded region, first we need to find the area of the sector, then we subtract the area of the triangle, and we will get the area of the shaded region. So the area of the sector is going to be the degrees, which is 90, over 360 multiplied by pi times the radius, which is 35 squared, minus the area of the triangle. Again, you're going to use the sine rule. So we know that this is 90 degrees. How do we know? Because the length of the arc is the same as the central angle, which is 90 in this case. So minus 1/2 times side. So this is 35 over here and 35 over here, because they are radii, times sine the angle in between them. So if you put it on the calculator, okay, let me put it on the calculator. 90 over 360 times pi, remember, use pi as 22/7, times 22/7 times 35 squared minus 1/2 times 35 times 35 times sine 90. We will get quite literally an exact answer of 350. So our answer over here is 350. We move on to the next question, which is question 17. The area of the circle whose circumference is 12 pi is k pi, where k is a constant to be determined. Okay, what is the value of k? Very simply, to find the area, you need to find the radius, and we know that the circumference is equal to 2 pi r. So in this case, it's equal to 12, divide it by 12 pi, sorry. So divide by 2 pi, you are going to get that r is then equal to 6. And now to find the value of this, we know that the area is equal to pi r squared. So in this case, it's going to be 6 squared times pi, so it's going to be 36 pi. So the value of k is very simply 36. We move on to question number 18. They said in the given figure, PQR is an arc of radius r and length 15. What is the length of the arc QR? They need us to find the value of the length of the arc QR. Okay, so we know that the radius r is 15, first of all. And they told us what? That PQR, okay, sorry, it has a radius r and length 15, my bad. So the length is 15. To find the length of anything, it is gonna be angle over 360 times 2 times pi times r. Okay, so we can find the value of r. We know that the angle is what? We know this is 90 degrees first of all, because this is given to us. Now this one is pi over 3. If you remember, whenever we have pi over 3, we substitute pi by 180, so it's 180 divided by 3, which is 60. Okay, so this angle over here is gonna be 60 degrees. So all in all, it's 60 plus 90, which is 150 degrees. Now, that means it is 150 degrees over 360 times 2 times pi times r is gonna be equal to 15 as a length. Okay, so 150 over 360, it is, let us keep it as 5 over 12 in simplest form. So 5 over 12 times 2 times pi times r is equal to 15. Okay, 5 over 12 times 2 is gonna be 5 over 6. So 5 over 6 times pi times r is equal to 15. Then 5 over 6 times pi, it will give us 5 over 6 pi times r is equal to 15. Move it to the other side, so that means r is equal to 15 over 5 over 6 pi. Okay, so 15 over 5 over 6 pi, we will get an answer of 5.792. So we found what now? We found the radius. So you're gonna put 57295, whatever. Okay, this is the value of our radius. So now let us find, okay, the radius, or sorry, not the radius, the length of the arc QR. To find the length of the arc QR, you're gonna take the angle, so 60 over 360, and then you're gonna multiply it by 2 times pi times the radius, which is this number over here. So it is gonna be 60 over 360 times 2 times pi times the radius. So if you put it on the calculator, you can put answer directly, which is gonna be the radius. So you are gonna get an answer of 6. So very simply, the answer over here is 6. So again, I'm gonna repeat what I did. First, I found the radius. How did I find the radius? I applied the rule that angle over 360 times 2 times pi times r is equal to the length. Okay. They gave me the length of PQR, and we know that this total angle is 150. So I found the radius. After finding the radius, I know that this is 60 over here. So then I was able to find the length of the arc QR, which is 6. Move on to question number 19, which is the last question. And guys, my voice is gone. I'm really sorry. The figure below shows a sector of a circle of center O and radius 10 centimeters. They need the area of the sector. Very simply, to find the area of the sector, you're going to apply the area rule. So it's going to be angle over 360 times pi r squared. So it is 108 over 360 times pi times 10 squared. Put it on the calculator, but do not include pi because they want pi in the answer. So it becomes 108 over 360 times 10 squared. And we will get an answer of 30 pi. So very simply, the answer over here is 30 pi. Let us submit, and hopefully there are no mistakes. Thank God there are no mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.